Most business applications are boring to look at, clunky to work with, and almost always do not talk to or integrate with one another. It's just too much work to get something simple done. Introducing Aloha DXP solution from Appfusions, bridging people, data, and silos seamlessly. Aloha DXP connects people, process, and data, and it makes every business application work with each other simply, seamlessly, and securely. Aloha DXP makes it easy for you to work smarter and get more done with a human-centered user experience. In an organization, bridge systems increase engagement and smooth relationships, bringing together technologies, people, and silos. Aloha DXP is leading the way and helps enterprises build flexible, integrated, and ridiculously simple digital business platforms for any device, any data, and any system. Don't just connect your systems, say Aloha.
Up here, we're going to be talking about how our two companies are actually working together to solve two different parts of the same problem. And so Craxel in and of itself, we build building blocks. We built databases and distributed ledgers, and we built you can click the next slide. We built a digital trust platform that really is going to transform the way we look at data and the way that we trust our infrastructures.
Good morning, thanks Donald. I'm Ashok Venkatraman, I'm with Appfusions. I'm their strategic business development manager. And so today I'm really excited to be sharing the stage with Donald to talk about digital experience platform and blockchain. And so Donald, we know that blockchain and distributed ledger technology is gone mainstream. But how do we tell what this is impacting in 2019? How is this impacting in 2019?
Sure. So one of the things that we know is the nature of work has changed. How we do work in an enterprise and a business has fundamentally changed. And our systems now have to modify themselves, or have to be changed to create the experiences that our workers demand, the efficiencies our leaders need, and the security that our consumers expect. So one of the things, when you think about a CIO's priorities, 3 years ago, what was the priority of a CIO? Reduce your cost. How can I make my IT cheaper? But today, as mentioned in the presentation before, CEOs are looking at CIOs and saying, I need you to not only improve our efficiency, but how can we use our IT as a strategic asset to make our business grow? Whether that's in the automotive sector or whether that's in e-commerce, pharmaceuticals, healthcare, you name it. Every CIO's mandate now is not just how do I reduce the cost of the services I have, how can I improve customer experience, how can I use information as a strategic asset to make my business grow faster. And to do that, we need to integrate the workers better, we need to integrate our workflows, our partner systems, and look at data as a strategic asset. And how do we manage that amongst the people and the organizations? And the three key things they need is more efficiency, more trust, and that enables a better digital experience. And so you mentioned blockchain. So rather than going through the blockchain bingo of every possible use case in supply chain and healthcare and how I can do that, blockchains are distributed ledgers. What they're really, really good at are three core things. Securely exchanging or sharing value. The Bitcoin experiment, I'll call it, has proven that to be successful. Is it going to do away with cash in a society? No, but it has proven that we can actually create trustless infrastructures and I can actually exchange something of value between two counterparties. Sharing information. That's the other thing blockchains and distributed ledgers are really good at, is take two organizations that are partners and the humans may trust each other, but their systems don't trust each other. Would you ever let a partner directly into your crown jewels of your company and your CRM system? No. But having a distributed ledger or that trustless infrastructure where we can actually share information between parties that inherently don't trust each other. And then the third thing is business automation. Well, now that I can publish and read and query and understand information in this trustless infrastructure, I can use that to facilitate business automation. There have been experiments in things like smart contracts, but it's more than just smart contracts. How can we use this to automate dynamic pricing in insurance industries. There are lots of IoT applications. But ultimately, these building blocks, what they do is they start to form the foundation of how we can use our data differently to create new digital experiences. But there are several missing pieces in digital experiences.
Yep, so the missing pieces, this is really a big part of our presentation, and we want to really hone in on the point about, first and foremost, you got to integrate the business. So when we say integrating the business, I think about the word integrated, and I get fascinated by this one definition for integrated, which is without contradiction. And we know enterprises today are always looking to invest more to integrate their systems internally, but there's more to this, which is how do you extend all this effort and time and resources you're putting in to integrate internally outside your walls? And how do you do that with your partners? How do you do that with your customers and suppliers? And that leads to this level of extensibility that creates opportunity to create new shared experiences with these partners and ecosystem, but being able to do that in a way where you need to be able to say, do I trust my enterprise data in the hands of someone I've not had a long history of doing business? And how do I make sure my enterprise data is in fact going to be used for the right intended purpose, not misused, and not being used for the competitor's benefit? So there are some challenges that still needs to be addressed. Going beyond, there is obviously opportunities to do more integration and taking your existing apps, combining it with your partners' apps, and delivering that in a way that you can create unique experiences and still figure out the right tools to develop those unique experiences. So there's a lot of opportunity here, a lot of barriers as well. But that said, there is this other foundational, fundamental challenge, which is how do you trust all this data that's driving these experiences, right? So back to you, Donald.
Right, so the next missing piece when we look at integrating that data, so I love that definition, without contradiction. That's what integrated is. But to do that, there's this dichotomy when we think of security. Everybody knows the security's pitch. Okay, the world's falling, hackers are everywhere, they're going to get your data, you need to do lots of stuff to protect it. We actually need to change that paradigm and think differently. Let's not fight harder, let's fight smarter. How can we actually prevent the attackers from ever getting a hold of the data in the first place? What if somebody breached your database and you didn't care? How can I trust the data in my systems and not have to actually trust the infrastructure that they're running on? That's been a big challenge in cloud migrations. I want to move all my data into this cloud that somebody else is running, and they're big companies with big reputations at stake, so I kind of trust them. But what if I don't want to? And what if I don't have to? How can we create zero knowledge, rely on the information and not the infrastructure? The other thing is rapid adoptability. Who knows of blockchain pilots in practice today? Everybody. Who knows of really successful ones that are impacting you directly? One hand. And one of the main issues in that is the rapid adoptability of these things. Enterprises are not fundamentally wired to grasp on to disruptive data technologies. We just watched a great presentation on Google and what they're doing in machine learning and how they're enabling new ways of looking at the data that they're collecting and improving your experience. So there's lots of very disruptive data technologies and AI and machine learning, but they're hard to actually adopt and use and grab. But that's what needs to happen. How can we create technologies and forget, again, of all the buzzwords of what blockchain is, but how can we actually use it and integrate it into a platform where all your other legacy parts of your infrastructure can benefit and enable the growth that you need to? And the last thing is reducing the cost of trust. Security costs a lot. And ultimately, there was a study done that looked at the amount of work that people do and how much of it is just enabling and managing trust within an organization. They said annually it's about $29 trillion a year. Well, that's a lot worldwide in terms of, and so what we need to do is how can we create infrastructures that can reduce that cost of trust, and I can focus on the business and not have to focus on the infrastructures and the enabling things. How can I rapidly pull together and compose my applications in unique ways, and the data just works with it. And for that.
Yep, so, integrating the business, integrating the data, these are some foundational building blocks. And what that leads you to do is to help you connect the enterprise. And this is where we believe it takes two companies that are in two different domains to come together to allow for this level of integration and connection to happen within any enterprise. And so as I think about Appfusions' product offering, Aloha DXP, which is a digital experience platform that allows you to mix and match apps in a seamless way. But what does that all mean in terms of the ability to mix and match apps? So the best way I could think of describing what Aloha DXP is I could think of an American company called Blue Apron. Some of you, if you're from New York, you probably are aware of this company. They're basically a meal kit service delivery company that delivers you in a box the ingredients and the step-by-step instructions for making a good meal. And you follow the instructions and you get a quality product out, and it's consistent and there is zero waste. Now, why can't we seem to duplicate that in the enterprise? We have lots of assets that we've already invested in, and we need to be able to continuously leverage this on an ongoing basis in the most efficient way with zero waste. So that's what we are trying to do with Aloha DXP. We have already built more than 24 integrations so that you don't have to worry about doing the hard work of back-end plumbing and engineering work and coordination. We'll do that. What I think we do different than other companies is our ability to give you the right tools for the right job. And by having the right tools for the right job, you allow your teams to come together, work on the same problem, with the same tools, with the same level of learning to achieve a common, unique experience that you want to be able to say, I did this not only so my internal users could leverage this effectively, but I can easily extend it, but extend it in a way that I can only extend it with the data that I'm willing to share. And I know at all times, what that data is and how it's going to be managed, right? So that's Aloha DXP. We are also a company that is mobile ready. We have a born in the cloud experience with our platform. And, tools like this are critical to bridging the divide, as you saw in the video in the beginning. Tools like this are very critical. So,
okay. So whereas Aloha DXP is meant to take all those applications you use in your enterprise and rapidly compose them for team-specific tasks, Craxel comes in on actually the back end of that. So we don't build front-end systems, we build the back-end databases, kind of like BASF. We don't build the products you use, we just make the products you use better. And we have two core products. One is the Black Forest database. And the next slide I'll talk specifically about what makes them really revolutionary. But we literally have looked at database technology and redesigned it and rethought about the rules of it. If you go into computer science literature, the fundamental principles of databases started back in the 1970s. And we literally have rewritten a lot of the rules on how they work. And we've been able to provide an unprecedented level of security and privacy. I'll talk about that next and exactly how we do that. But we basically made a database that if it gets breached, you don't care. We've added pervasive compartmentalization, and what that means is that as you put data into it, we have very fine-grained access controls and mechanisms so that you can be very specific on who can access it, who can see it exists, and who can actually see what it is. The performance we have is absolutely remarkable. I'll talk about it on the next slide, but it really will blow your hair back. And then the scale at which we can operate. The other side is So we created this DNA for a database. Like I said, we literally rewrote some of the rules of computer science to do it. And after we did that, somebody said, well, what about blockchain? And this was years ago, and we thought, well, what is blockchain? So we started looking at it, and then we realized the core DNA that we had in this fundamental database technology, we can actually apply to the way distributed ledgers work. And so we created the Black Forest distributed ledger. And two of the main problems in blockchain today are security and performance. Performance. Bitcoin network operates at about 5 transactions a second. You know, Ethereum can maybe go up to 100 transactions a second. IBM's Hyperledger has been tested about 1,500 per second. And everybody thinks about, you know, global payment systems. Well, Visa alone publishes that they average 7,500 per second. Just credit card transactions. That's not bank transfers, that's not SWIFT transactions, that's not all the other transactions that are going through the financial sector. So the performance is one of the major hindrances to adoptability. We saw the Uber use case, 200 rides per second going on at any time. Well, think of the amount of data that's actually just coming from Uber. So each ride is publishing its location every second, its destination, the time. They have to publish that. So with that, I imagine they're looking at thousands of transactions per second just to facilitate their core ride sharing, let alone all that other stuff that they were doing with food delivery and healthcare and all that other stuff. So when we think of performance, that's one of the main barriers in blockchain today is the systems that exist today just cannot satisfy the enterprise demand for more performance as the volume of data that we have to manage grows exponentially. The other thing is privacy and confidentiality. So does everyone want to put their enterprise's data in the clear on a distributed ledger so everybody can see it? I don't. But that's how a lot of these systems work. You have to publish your information, and then there's this distributed consensus mechanism that validates that that's the right information. But how do I keep it private? How can I share it with just the people I want to share? I want to rely on this trustless infrastructure. That's the beauty of these distributed ledgers and blockchains is I no longer have to trust the infrastructure. But now I've got to share all my data on it, which is hard. And then the other thing is consistency. So some of the use cases, I'll pick on Bitcoin because it's easy. One of the things in Bitcoin is when you initiate a transaction, it may be several hours later before you get a confirmation that that transaction has in fact been committed to all of the nodes. Well, that's not sufficient. The point of these things is instantaneous transfer. And so the property of strong consistency, when I enter a transaction, it's committed immediately, and when I query it milliseconds later, I know what the answer is. So how did we address those? So one of the fundamental things that we did was created this concept, and we figured out how to do it, of searchable encryption. People have been trying to do this. It was envisioned years and years ago, but about 2009, an IBM researcher, Craig Gentry, actually proved that something called fully homomorphic encryption was possible. What is fully homomorphic encryption other than a mouthful? What it is I can encrypt data, put it somewhere, and I can actually do computations on that encrypted data and then get the response back and then decrypt it, which means that, again, I no longer have to trust the data because it's in ciphertext. I have a good friend in the government that says, you know, modern encryption technologies, there isn't enough electricity in the world to power the computers that have yet been invented that it's going to take to break modern cryptography, particularly as you look at some of the quantum-proof stuff. So we can trust cryptography, I just can't trust the implementation on an infrastructure. But the problem with fully homomorphic encryption is that it's about 1 trillion times too slow. So think how fast it takes your computer to calculate 2 plus 2. With fully homomorphic encryption, it takes 1 trillion times that much. Again, that bites into that performance thing we were talking about. What we figured out how to do in Craxel is on the top right. So the right side is the database, left side is the ledger. Right side in the database, we can take your data, and those are the green boxes, encrypt it with any different type of key, store it in an infrastructure. So everything in the gray box at the bottom, we call it the data layer. And that data layer actually never sees the keys to that data, which means that we can put all the data in a cloud in fully encrypted form. Lots of other technologies can do that too, right? But the problem is, how do I get it back out? If I know exactly what I need, I can go get it. But what if I need to search? I need to search all of that encrypted data and find all of the records for the last week. And you can't do that if it's encrypted. But that's what we solved. So not only have we solved the problem where I can take data, put it in any infrastructure, cloud infrastructures, private clouds, on-prem, wherever you want, and whoever has access to that infrastructure never sees your data. If a hacker breaches that, great. They got a bunch of ciphertext that they're not going to be able to do anything with. But the other thing we did when we built this is performance. We always stayed true to the fact that the more performant the system is, even if your enterprise doesn't need all of that performance, it makes sure that you're future-proof. So our database we have tested on 33 nodes in an Amazon cluster. So we just rented 33 servers for $1 an hour on Amazon, and we simulated 8 million transactions per second. So put that in perspective, that's literally like 1,000 Visa networks on 33 computers in an Amazon cluster. That's pretty remarkable performance. So we built a system that can provide the trust that you need in your data. You don't have to trust the infrastructure, and it will handle any load you put at it. We then extended that to the distributed ledger. So on the left side of the chart, the same core DNA. So the information that we can put in a distributed ledger, it can be fully encrypted. And let's say you have two partners that want to share information together. We've talked a lot about information sharing. And this is both within an organization and outside of an organization. You can publish it to a ledger. And the benefit of the ledgers is that when you publish information, it's cryptographically signed so you know nobody can manipulate it. And it's always there. So the integrity of that data is always preserved, so you know exactly what was posted, and you make sure whatever you want to share is exactly what's posted. But we can encrypt that, which means nobody else can see it, and you can share the keys. There are lots of secure mechanisms to do that with your partners, and then only they can actually retrieve that. So it creates a trustless way for enterprises to collaborate better. And so when you can take Appfusions platform, where you can compose all the different applications that organizations are using, couple that with a mechanism where we can now connect these enterprises in a seamless way, very quickly, because you no longer have to go through all the security and legal and protocol checks that happen if you try and get two organizations to collaborate together, because you're using a trustless infrastructure. And the last thing I'll add, in our distributed ledger, there's a lot more overhead with the cryptography, with the signing of the chains, but we've designed it and we've tested it on 9 computers in Amazon at about 200,000 transactions per second. So again, most modern blockchain technologies, some of the best are hovering around, a couple thousand transactions per second. And we've literally added 2 zeros to that. And that unprecedented level of security. So the 2 fundamental problems in blockchain we've addressed, security and performance. And when you can couple that data layer, that trustless data layer, now enterprises can start thinking about using their data as a strategic asset. Your chief information officers are using that information to enable business growth, to enable those customer experiences. So when you couple that back end with a rapidly composable front end that you get from Appfusions, where they can take all those applications, connect them to the data, and connect them with each other, and different teams can pool them together, that's what creates the digital experiences that we need next.
So bringing the story together, this is no secret, Donald. When we first started talking about our partnership, there were 2 things that really excited all of us at Appfusions as we started having our conversation with Craxel. One is their ability to do the searchable encryption and search in encrypted data, and their ability to essentially demonstrate speed, which is really unheard of in the distributed technology world. And to me, this is critical, because when we think about a frontier technology like blockchain that is not easily understood by most enterprise users, or even consumers for that matter, how do you bring the accessibility with the same level of security, with the same level of speed we expect today with a lot of the existing technologies? Because the question is, why now, why this, right? And why now, why this is because we believe that by making such technologies that have come a long way through innovations that you guys have achieved over 10 years, this is what we need to be able to do, which is compose new digital experiences rapidly at the speed of the business, not at the speed of the IT monetization. For those of you who've lived in large companies, you would know what I'm talking about. I came from a very large, card network company. I can tell you half the products were built by lawyers and information security folks. And they defined the rules of the game on what that experience is going to be for your customers and consumers and partners and suppliers. There's nothing wrong with it, but it has to be done in such a way that if you can demonstrate that you can still stay compliant with the data, you can still keep it secure, you could go further with your experiences, in what you could co-create, which is really the message of this slide, is co-creation. And you need to be able to rapidly co-create new experiences with your partners, customers, and suppliers. In terms of other things enterprises look for, they're looking for, solutions that can scale. It has to scale. And they're looking for solutions that gives them, tens, hundreds, millions of options in terms of blueprints, data, systems that you could integrate with, right? And they're looking for something modern. So when you talk about a digital experience platform, are you using a modern technology stack? So that brings us close to the end of the presentation.
And so, as I said before, the nature of work is changing. And CIOs are demanded, or they're asked, they're begged, and they're pleaded for with their CEOs, use our information better to grow our business. But to do that, we have to create better experiences for the workers in those companies, security that the consumers demand, and the efficiency that the leaders expect. And I think back yesterday, Ben's presentation from IBM, I don't know if y'all saw it, but he had this great chart, and it talked about the 4 different types of businesses, from modernizing their operational efficiency to innovating on customer experiences. And he focused on the right-hand side of that chart, and the two types of organizations that you want to be are the industrialized, but ultimately the top right of that quadrant was the future-proof. And some of the properties that I was thinking about in future-proofing an organization that were listed up there is using your data as a strategic asset. But to do that, it has to be usable, and usable in better ways than it is today, because right now modern data management technologies are too hard to secure and too hard to manage. So we have to simplify that. But you also have to create a much better customer experience. And I'll say not only a customer experience, but also an employee experience. Competition in technical enterprises is massive today, and employees have to be empowered to have a great experience with the assets that they have to do their job. And then lastly, being modular and flexible and ecosystem ready. And so that's what we've done. We've created a new way of looking at your data layer at Craxel. Appfusions is creating a new way to look at how you integrate the legacy applications in your infrastructure and rapidly compose them for your workers. And with that, we believe we're on the start of a new way of looking at digital experiences and digital transformation. Thank you.
Thank you.